As Bender would say, 01111101. This is Visuino component creation number 125 for all of those that did not understand that. And this is how you can easily add some automation using the Arduino initialization and system loops that are already built into the IDE. Yeah, I'm going to show you how to keep all your pins ordered the right way, so they match all the other pins on all the other components that are already in Visuino. Because if you get them wrong, or you might say back-asswards, you might send some stuff to the wrong pin on another friggin' component. You never know. Or it might just look all crisscrossy and crappy and you just don't like it. Or maybe even there's another friggin' component somewhere else lurking in the sketch that you need. Yeah, and then that other component is lurking in the background. It's still sending the right stuff to the right place. Yeah, but maybe it's going to the wrong pin. And just for one reason. Because you already changed a bunch of crap to fix the first bunch of crap you got wrong. So you get all pissed off and chuck it over to the side for a later time. And just stop doing that. Watch this video. And I'm going to show you how. Wow, I can't wait. Oh, hey, just playing with my robot here. Anyway, we're going to go over a few things, and thank you for watching the video again. Today we are going to go on about how to set up your initialization through the IDE and your main loop. Those are the two that are called most of the times. I mean, not for hardware setups and things like that, but if you got to set up your values before the program starts running, that's where the Arduino start comes in. Now, Arduino loop begin is another command that's used in the vcomp file that sets every time the loop runs, then a certain part of the code is going to run. There's another section you can put in is a public void for the input pin calls, and if it gets a receive, like O receive or O connected or something like that, then it'll automatically trigger it, kind of like another software interrupt or hardware interrupt, whatever one you're using. And then also we're going to show you how to name and set up the vcomp file. So if you want, for some odd reason, you want a clock pin above an input pin, I don't know, you would name the clock pin at the bottom of the vcomp file first, and then above that you would put the input pin, because it's set up from the bottom up, not alphabetically in the vcomp file. When you set up the type names in the class and stuff like that on all the pin calls, and you're setting up the type names, then everything is in alphabetical order. You set up your diagram the way you want the actual component to look in the vcomp file. It sets up the list alphabetically, and then you have to attach to that. Normally you do not ever have to set up your input pins. OpenWire takes care of them. Now there is another command called OpenWire exclude bindings, and that is so you cannot set the property as a sync pin or a sync value. You can enter a new property, but you cannot attach a sync pin. Now OW primary pin, OpenWire primary pin, gives you that option if you're setting it up as a property. So there's a couple ways you can go about it, and let me get into it and show you a couple little tricks that I've learned. Okay, so to get set up, you need to go visit my Patreon. There is no need to donate to get the files. That's just leave us a like or whatever, just go. That's where they're going to be. What is in it is all of the 4 test files so far, A, B, C, and D. We're on D, obviously, and the only thing this really does is it's got a counter. You're feeding it a number, okay? I've got the counter here set to 70, and then the trigger is set to 50. as the counter counts up, the trigger number is going to count down to 0, which is 50. When it goes past 50, the pin, the output pin, is going to turn off. If it's above or below 50, like 0 to 49, it'll be a true value. If it's anywhere above the 50 point, 50 to 70, 51, whatever, it'll turn off. So basically it's just turning it off and on at a given number from 0 to 70. Okay? So all you gotta do is just go get the files, extract them, and stick the folder into your library's testing. If you have a current testing folder, please delete it. Alright, let's get into it. You should know what the first few lines of this does. It sets up the name, it attaches the library, it tells it what it's going to call it, and it attaches it to the testing namespace. If you don't know all that stuff, go back to the other videos and watch them. Here in line 8 and 9, Arduino start and Arduino loop. Now this is where it actually physically attaches the test D sketch to the code in Visuino. I'm going to show you right here. If you look at the very last lines of the code tab up here on Visuino, you know, main is where your sketch is and all that, okay? So, but if you go to the code tab, alright, let me let this computer catch up for a second. It's an old Tinker box, but you'll see right here where it says void setup, and then down here, void loop. This is at the very bottom of the code tab. And the last lines, test D1 system start. That is where we're starting it in the setup files. It is the last one. Remember that, because if you're expecting it to load first, no, you're going to have to make sure what you're loading is loading first. And then also on the loop, it's also the last to be declared in the loop. Okay? Okay, now starting at the top of the list of properties and pins, we see the OW exclude bindings. That's open wire exclude bindings. And that is the property of trigger. And it's an integer, and we're setting it to 50. If we were to remove that OW exclude bindings, you would be able to click on it and set a sync pin. And then moving on, right here at line 15 and 16, the first side, I like to set my input pins first. And like I said before, it's going to work its way from the bottom up as it's reading these. So this input pin, this integer sync pin that it's setting on line 15 and 16 is going to be the first one that it sets. So if there's another one after it, it's going to be above it. Okay? And the same thing with the output pins here. The source pins are outputs, sync pins are inputs. OW primary pin, trigger pin, and output pin. Notice in the picture over here, I have output is the integer at the top and trigger is the digital at the bottom. If you look at the list here, output is listed last. So it works its way down the list, and whatever is last on the list is the last to be put on top of the stack. Okay? Inputs, outputs, separate. You can line them up, you can put them in wherever you want, you can mix them up, but they're all gonna end up input, output. They won't all conglomerate into one group. That's a different video. So this is a time where I get to beg you for your support on the YouTube video. Feel free to like, share, comment, subscribe, or don't. It's all good, man. And also on the Patreon, there's no need to donate, but just please go like and visit. That is where all the files are going to be available. Besides, you wouldn't want another robot to accidentally get broken, would you? And I was told by studio personnel to make sure that you know that no live robots were harmed in the making of that little video. That's a tough robot. Nothing broke on that thing except for that old RC receiver circuit board. All the other pieces were just fine. That's some tough stuff, man. But anyway, let's look at the H file here, the testing DH file. I'm just going to get down to 12, 15. This is, you know, if it's not defined as the testing DH file, it's going to define it, and it also includes the file into the code tab. We're setting it to the namespace of testing. Now here, the template is where it's important. Remember, don't set type names for your input pins. You want to do your properties and your output pins only. You can set input pins to different categories, like you can set a type name to input pin on receive and have it do something else if it's received in a different state. But that's again a different video much farther down the road. Just remember, alphabetical order, and you do your properties and your output pins together in the same list in alphabetical order. You first name them in the template as the type name, and then you set the class. Remember, the class is where we set it right up here. Create name, right there. That and Arduino class is where we're setting the name and referencing the H file right here for this type name template. All right, and then we're also declaring all those properties and output pins as public access to the outside so it can communicate. All right, so then you would have to declare the properties and pins, what they are, moving down the line of your template. First one we get to is the enabled. That is a property, so we're going to declare it as a public property, and it's enabled. And the next one down the line is the output pin. It is an output pin, so I like to keep it in order. You don't necessarily have to, but you change it from a property to a virtual pin in that declaration. And I assign it to another public just in case I got to add code or change it. And then the next one is the trigger pin. And then again, I would change it to another public declaration to back to property for trigger. And then the last one is the trigger pin. And then, so it's the last one in the line, and since it went from property pin, I just named them and switched. You gotta reclassify them as a property or a pin for each one. And then after that, we just declared ourselves a few public two integers and a Boolean value, false. And then the difference is it's gonna subtract the input from the trigger value, and then the input value is what it's gonna set it when it receives the data. Now this input value is important because this is the part that comes into play in the actual loop, in the Arduino loop. Okay, lines 45 and 50. This is where it's pretty much just like guess what? Got to do something now. The input pin, whenever it receives data, the void is input pin on receive. Remember, you did not declare your input pins above in the template. So whenever it receives some kind of data, it's going to raise a flag, say, hey, we got to do this right now. But this is during the calling of the actual component structure, not the actual system loop. When it gets around to the component, if there's an input value there, then it's going to do this for the input pin on receive. Okay, now down to the part that you've been waiting for. Right here is the system start. What we're doing at the system start, which is the first portion of this component when it runs, is it sets this in where we showed you in the code tab. It triggers, it's going to send out the trigger pin, set the pin value, whatever the output is. Now remember, we're setting the output right up here as trigger output as false. So it's going to set up as soon as the component starts and Visuino starts running and Arduino starts running, it's going to send a false as an output and turn it off. First thing. I moved myself so you can see a little better. But anyway, on to the system loop. Now these are inline voids. What it basically says is it can happen whenever. If it's a regular void, it has to be called during the component run. First thing it's going to do is check and make sure it's enabled. If it's not enabled, then it's just going to return and not do anything. It's going to find our difference. Difference is going to be equal to whatever our trigger value is, whatever we set that property to, minus what our input value is currently. 57. We're going to send that value, the difference value, out the output pin of the integer output pin. Okay? T output set pin value difference. Here is where we check if the difference is greater than or equal to 1, then our trigger output is false. That means that we still have numbers to count down to 0. We haven't not yet reached our trigger point. If the next one, if the difference is less than 0, then trigger output's going to get turned to true. Means, hey, we've hit it and we've gone past it. All right, and then finally, during the void loop, we are going to set the trigger pin to the trigger output, whether it be false or true. So it's going to turn it on or off, whichever one it is. And that is it. That's the whole story. Yep. That's it. So yeah, now we can update our trigger value to whatever we find. Let's go to 25 here. And let's go ahead and upload and compile that. And let's make sure that it's actually going to turn on and off at 25. It should. It's loading. There it goes. Working so far. Yep, 25, counting down. And it's finally hitting 0 at the count of 25 and turning to true. There we go. Remember, alphabetical order. Do your properties and your output pins. Declare your input pins is on received or something like that to get used to it. And like, share, subscribe, comment, or don't. It's all good. Peace. Thank you for watching the video, and go check it out on Patreon to get the files. Peace.